So, welcome to my dear learners and students. So, today I'm just going to discuss about a concept called tuned mass damping. So, basically, this I am giving you a very brief idea what is tuned mass damping. Basically, it is used in for some critical structures like high-rise buildings or um, some strategic structures for nuclear plants where the reactor mainly the reactor containment building or the reactor dome. So mainly this is a seismic protection. So when the earthquake is coming, so due to that um, earthquake, the building or the civil structure will resonate. Means if it is uh, the frequency, if it is matches, if it match with the um natural frequency of the building, then it may collapse. Okay, and another thing, when the vibration occurred, how quickly it will be damped and it will rest within the tolerable limit. So this is one schematics where you see when that any force due to say you can consider this is a high rise building or a reactor dome or whatever may be the things. So due to wind, you can consider it's a high rise building. Okay, so due to wind or the during the seismic condition, this building will try to uh, vibrate. Okay, so it will move like this. Okay, so you see the first it will try to move in this direction. There will be a displacement x1 from its equilibrium. Then again, based on the damping, it will again come back. It will go this direction from its equilibrium is x2, and slowly this your x2 will be less than x1, then x3 will be less than x2, and so on, and slowly it will there will be initially there will be a transient, and slowly based on the um, uh, damping ratio, this will uh, the vibration will come down. Okay, so the here the thing is how quickly the transient will be decay down and it will be maintained within the tolerable limit. So for this, what is introduced? Simple a mass here. Okay, so you know this will work as a pendulum. So simple concept, very simple concept. So when there is a due to the seismic force or some wind force, when the building or the structure will try to move this direction, then this pendulum will try to move in this direction, and that energy it will be dissipated here. Okay, and vice versa here. When it will be going that direction, then this pendulum will try to move in this direction. So the energy due to the external excitation that will be dissipated through the pendulum, and it will cause the uh, movement of the pendulum. Okay, so simple. So that recently I got one simulation task from some company. I have to simulate it. So the calculation and how to, what is the calculation is also very simple. You know, the pendulum, the first you uh, what you do in simulation method, because exact same scale uh, implementation means physical experiment is not possible, because it may be a destructive test or experiment. So first you today there are a lot of tools are available like COMSOL, SolidWorks, ANSYS. So there first you make the building, you define the, you make the geometry, define the material based on the design, you make it, and you calculate the eigen frequency, that is the natural frequency of the structure. Okay, then you design a pendulum. That pendulum thinks it is, you know, that the time period of a pendulum, it will be 2 pi root over L by G. So you design a pendulum system and suspend here that the time period. So say the frequency of the natural frequency of the building is f. So you define, you make the time period of the pendulum t, which is 1 by t. Okay, and how much this pendulum, how it will work, that I will explain later. Here I am trying to just give you the brief idea how the tuned mass, the concept of tuned mass damping. So which, how much you are allowing to move this pendulum base, that is because this cannot go, this pendulum, it cannot go here because it will hit the structure. So that all these things, it is depend on how much force it is getting developed due to the acceleration, the external excitation, how much force will be developed in the mm, uh, this mass, and how much it will be displacement, all these things it will be calculated based on that, and based on that you can design the tuned mass damping. So this normally the when I was in Taipei, so there this all the high rise building, they are implementing this concept, because those area highly seismic, those are the highly seismic zone, and nowadays in nuclear reactor application, mainly in the dome, Korea, all other country, like where the uh, there is a possibility that those are the highly seismic zone, there people implement this concept. Now one video I, one animation I got, with that I will end, and I will show you that at the end of this discussion, so that you can understand. So now you see here, when the external force applied, you know, this was the earlier, you see this, if you take the envelope, it was like this, it's a natural damping. But you see, once you introduce this tuned mass damping system, you see how quickly it is getting decay down, and the amplitude is controlled within the limit. So this is the basic concept behind tuned mass damping system. Now I will come to the animation. Now here you see, sorry. So in that picture, what here, the first one here, it is the mass is, the pendulum action is not there, and here you see what is done basically. the first, the natural frequency of the uh, this structure is computed, and after that the length, because this length is set to match the natural frequency of the structure and the frequency of the pendulum. So once it is done, and now you see, for the same extent of external excitation, the where the tuned mass damping is introduced, how quickly it is coming to, how quickly the amplitude of the vibration is decaying down, and it is coming nearing to the rest or within the tolerable limit. So this is basically the things, and the same kind of things I am going to simulate. um, I don't know whether in the subsequent, in the next one video, I will try to share you how to model it and how to calculate it, what is the physics or the mechanics behind it, uh, but I may not able to share you the exact structure what I will be doing. I will be making some uh, indicative uh, geometry or structure, so that you will be able to understand the things. So hope mm, this small concept, this simple concept of tuned mass damping you have understood. So thank you so much. Thanks for your patience.